Hey there, this is the first day that we're doing anything with trigonometric angle formulas. Okay, and the first one that we're looking for is the sum identity formula for cosine. Cosine of A plus B. Okay, these are Greek letters alpha and beta. Hang on, pause and let me show you what I'm looking at. This is the sheet that I am talking about. This is what all of my students have in their possession, because it has all the formulas on here that we're ever going to need. Yes, it's bright and it's yellow and it's made of cardstock, so you should never lose it. You should bring it to class every single day, because we're going to refer to it every single day. So cosine sum, that would be the cosine and plus, because sum means plus. So here is your cosine sum formula. It says you take the cosine of the first angle and you multiply it by the cosine of the second angle, and then you subtract the sine of the first angle times the sine of the second angle. Okay, there's a formula for everything that we're going to do during this unit. So there we have your formula. Now we're going to use these formulas to find exact values of non-unit circle angles. Remember, our unit circle angles are 30 degrees, 45 degrees, 60 degrees, 90 degrees, and so on and so forth. Okay, so we're going to find other angles using your unit circle angles. So the first thing that we want to do on all of these problems is find two angles from your unit circle that add up to 75. Okay? Two angles from your unit circle that add up to 75. 30 and 45 are two excellent angles that add up to 75. Okay, so we're going to use our formula for the cosine of two unit circle angles that I'm going to add together. Okay, so once I identify those two angles, now I use the formula. Now that it's in our formula, we're going to go to our unit circle, and we're going to figure out what each of these values are from your unit circle. Okay, not from your calculator, not from well, I guess you can go to a graph, but from the unit circle. The cosine at 30 degrees is root 3 over 2. The cosine at 45 degrees is root 2 over 2. Minus the sine at 30 degrees, which is 1/2, times the sine at 45 degrees, which is root 2 over 2. So all of these values come from your unit circle. We are evaluating the cosine at 30, right? We're not using a calculator. We're using the unit circle to find an exact value, not a decimal approximation. So now I have some fractional algebra, right? I need to multiply fractions together. And how do we multiply fractions? We do top times top and bottom times bottom. Same over here, top times top and bottom times bottom. So what, pray tell, is root 3 times root 2? Well, that's the square root of 6. And 2 times 2 is 4. Okay? And then minus 1 times root 2, which is root 2, divided by 2 times 2, which is 4. And my last thing, here I have a subtraction of fractions with the same denominators, which means I can subtract my numerators. But here's the deal. We can't actually, quote unquote, subtract these two things because they don't have the same exact radical. So our answer is this: root 6 minus root 2 divided by 4. Very good job. Okay, now the second one here is the difference identity for cosine. So cosine minus. Once again, here's our sheet. Cosine minus is right here. The cosine of subtracting two angles is the cosine of the first times the cosine of the second plus. Notice this has a plus as its operation between these two things. Sine A, sine B. So now let's look at a problem. This says find the cosine at pi over 12. Also not a unit circle angle. Okay, and since it's under the subtraction part, I'm going to think about two angles that might subtract each other to get pi over 12. Okay, so this is how your brain needs to start thinking about these things for this, right? So we're just going to do something over 12, some amount of pi over 12, minus some other amount of pi over 12. Okay, so these numbers that go in the first slot and the second slot need to subtract to give you what? They need to subtract to give you 1. Okay, if your answer is 1 pi over 12, then we want some amount of pi over 12s minus a different amount to give you 1. So give me two numbers that subtract to give you 1. 2 and 1. How about let's try that? 2 pi over 12 and 1 pi over 12. So let's do some simplifying. What does 2 pi over 12 reduce to? Pi over 6. Is pi over 6 a unit circle angle? Yes. Check. What about pi over 12? Does that reduce? No. Is pi over 12 a unit circle angle? No. So these are not two very good choices to begin with because they don't give me unit circle angles. So we get out our eraser and we erase these things. It's perfectly okay to erase some things and try again. So let's try again. What are some other numbers that subtract to give me 1? 4 and 3 or 3 and 2, those both work. Let's do the smaller of the two just for fun. 3 minus 2. Does 3 minus 2 give you 1? Yes. What does 3 pi over 12 reduce to? 1 pi over 4, right? I divide both of these by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. And what about 2 over 12? That reduces to 1 pi over 6. Both of these are unit circle angles. So now I can actually employ this formula. Okay, so you have to make sure that the angles you are using to subtract are actually on the unit circle. Okay, so then our next job is to plug into our formula. So it's important to get the signs correct because pi over 12, that's a first quadrant angle, right? 1 pi over 12 is less than 30 degrees. It's actually 15 degrees. So we were expecting a positive value for sine and cosine if we're in the first quadrant, right? In the second quadrant, sine would be positive and cosine would be negative. So make sure that we are getting the things that we are expecting. So now let's go to our unit circle. The cosine of pi over 4 is root 2 over 2. The cosine at pi over 6 is root 3 over 2 plus the sine at pi over 4, root 2 over 2 times the sine at pi over 6, which is 1/2. Okay, so all of these values are coming from your unit circle. Okay, so if you don't have a unit circle handy, find one on the internet, look at it, or print it out so that you have it to look at. Because after this, the multiplication is pretty simple. So we do top times top. Root 2 times root 3 is once again root 6 plus root 2 times 1 is just root 2 over the same denominator of 4. So this is our answer for the cosine at pi over 12, right? The exact answer. Root 6 plus root 2 divided by 4. So maybe you're noticing some things here, which is amazing and awesome, that we're always going to have root 6s and 2s and 4s in our answers for these kind of problems. Okay, because the sine and the cosine can only be root 2 over 2, root 3 over 2, or 1/2. I guess 1 or 0 also, but these are your answers. So this is what we're expecting everything to look like. Okay, the sum identity for sine, moving on. Find it in your chart, write it down. So here's where we find that on our sheet from class. Right, we have sine cosine plus cosine sine. There we go. So it says find the exact value for 7 pi over 12. Once again, we need to think about two angles that add up to give me 7 pi. What two numbers add up to give 7 maybe? 3 is do 3 and 4. Okay, 3 and 4. I know 5 and 2 work, but I also know 5 over 12 does not reduce and is not a unit circle angle. So 3 and 4 will both reduce. So 3 pi over 12 reduces to 1 pi over 4, and 4 pi over 12 reduces to pi over 3. So we're going to employ the sine sum formula with pi over 4 and pi over 3. So first thing we do is plug it into the formula. There we go. Now we go to our unit circle and we find all of these values. Sine at pi over 4, root 2 over 2. Cosine at pi over 3, 1/2. Cosine at pi over 4, root 2 over 2. Sine at pi over 3, root 3 over 2. Okay, and employing that same exact algebra we just did, root 2 times 1 is root 2. Root 2 times root 3 is once again root 6, all divided by the same denominator of 4. And that is our exact value for the sine at 7 pi over 12. Our next problem wants you to do this difference, the sine difference. So once again, that formula, like that. Okay, that comes from our chart. So, and this says find the exact value of this equation, right? So now they're giving us an equation, and the job is to recognize this equation as the same as that one. Okay, so this is a sine subtraction equation where A is 80 degrees and B is 20 degrees. So we're going to replace A with 80 and B with 20. So working backwards, this would be the sine of 80 minus 20. This equation comes from that part of the problem, right? That identity, those are identical. Now I know what 80 minus 20 is. 80 minus 20 is 60. And sine 60, well, that just comes from your unit circle. The sine of 60 is root 3 over 2. Okay, so this case we're working backwards. They give us the formula, or they give us our equation, and they want you to recognize where that equation comes from so that you can do a quick little simplification. Okay, the bottom 3 questions on your assignments want you to do that. Okay, let's move on to the mathematically challenging stuff. The sum identity for tangent has 2 parts to it. It has a numerator part where we add together the 2 tan values, and it has a denominator part where we subtract the product from 1. Okay, so this is your tan formula for addition. And for subtraction, it's very similar, only the minus and the pluses change places. Okay, so this is what we're going to use when we're doing our tangent things. Okay, so we want to find the exact value of the tangent at 19 pi over 12. 19 pi over 12. Okay, this looks like it's a 3rd quadrant, maybe a 4th quadrant angle. So we're expecting it to be negative. So let's see. What 2 numbers add up to give you 19? Right? That's our first thing we got to find is 2 numbers that add up to give us 19. 9 and 10. Those are 2 wonderful numbers. 9 plus 10. Okay, 16 and 3 would have also worked because once again we need to be able to reduce these. 9 pi over 12, when we divide them both by 3, is 3 pi over 4. 10 pi over 12, when we divide them both by 2, is 5 pi over 6. Right? Both of those are unit circle angles, so now I can employ my formula. Okay, so my formula when I plug them in looks like this. Now our next step is to go to our unit circle. The tangent at 3 pi over 4 is -1, plus the tangent at 5 pi over 6 is -√3 over 3. Okay, remember tangent is a y over the x, the sine value over the cosine value. Okay, and then we have from your formula 1 minus. And then the tangent at 3 pi over 4 was -1, and then again multiplied by -√3 over 3. Okay, let's do some simplifying. Plus a minus, well that's just the same as a minus. So the top becomes -1 minus √3 over 3. And then on the bottom I have a negative and a negative and a negative. That just becomes 1 negative. So 1 minus √3 over 3. Now, no, nothing just cancels out, right? You only can divide when there's exactly the same thing. This is a -1 and a minus, which is not the same thing as +1 minus. So now we turn to our algebra. In order to combine these, right? In my basic thing, I have a number minus a fraction. So I need to change my -1 into a fraction that can subtract this fraction. So my denominator on the top is 3. So I'm going to change my 1 into 3 over 3. Because 3 divided by 3 is 1. I haven't changed anything mathematically. Same thing on the bottom. I'm going to replace my 1 with a very fancy looking one. 3 divided by 3. And I do this so that now I have fractions that can actually combine, because my denominators are the same. Okay, so I have a -3 minus √3 divided by a single 3. That's my new numerator when I combine when I subtract these fractions. And in my denominator, I have again a +3 minus √3 over a single denominator of 3. Okay, so this is how we subtract fractions. We change that 1 to be a fraction so that we can combine them. Now, a little math hack. If I have two things in fractions divided by the same denominator, right, when we multiply by the reciprocal, those denominators are gone. So this becomes a single fraction, -3 minus √3 divided by +3 minus √3. Okay, so here we have the situation where we have a radical in the denominator. Mathematicians don't like to have radicals in the denominator. So there's a process that we use in order to get rid of the radicals, and that's called multiplying by the conjugate. And you say, all right, what's a conjugate? Well, we've had conjugates before. Like what happens when I do x minus 3 times x plus 3? Okay, this two-term binomial, when I distribute this and combine like terms, turns into x squared minus 9, right? One of the terms, the 3x and the minus 3x, get eliminated. So this x minus 3 and x plus 3 are conjugates. Okay, these are conjugates. So then what is the conjugate for 3 minus √3? Because remember, we're just worried about the denominator. The conjugate of 3 minus √3 is 3 plus √3. And we can only multiply by 1, so we have the same thing on top and on bottom. So now our job is to multiply these things all out. So one at a time, I'm going to do -3 times +3, which is -9, -3 times √3, which is minus 3 √3. And then I'm going to come back and do -√3 times 3, which is -3 √3. And then -√3 times +√3. And when I multiply a radical by itself, the radical goes away. So that's what my numerator looks like when I distribute everything. So let's see what my denominator looks like when I distribute everything also. So 3 times 3, right, that's positive 9. 3 times root 3 is positive 3 root 3. And then I'm going to distribute my negative radical 3. So negative root 3 is a minus 3 root 3. And negative root 3 times positive root 3 is minus or negative 3. Okay, so all of this wonderful algebra that we have to do in order to simplify. Okay, so now we're going to combine our like terms. Combine like terms. So I have a number 9, an integer and an integer. Negative 9 minus 3 is negative 12. Okay, I have negative root 3 and another negative root 3, which add together to give me minus 6 root 3. Because minus 3 and minus 3 is minus 6. Okay, in the denominator, I have 9 minus 3. 9 minus 3 is 6. And then I have positive 3 root 3 and negative 3 root 3. Those add to give you 0. Okay, that's the whole point of multiplying by the conjugate, because now my denominator is just a single number 6. So much nicer than having radicals all around. And the last thing we can do is notice what divides. Does 12 divide by 6? Yes, it does. Does 6 divide by 6? Yes, it does. So we can do both of these divisions at the same time to give me a final answer of negative 2, because that's negative 12 divided by 6 minus 1, so we don't have to write a 1, root 6. And this is your answer. Okay, there is a lot, I know, there's a lot of algebra in here, a lot of algebra simplification to get from where we started at the tangent of 9 pi over 12 to get to the single answer of negative 2 minus root 6. Okay, but that's what the expectation is. So this is the first time we've ever done it. So maybe the second time will be a little bit better, which is going to be number 8 here in a minute. So maybe we won't have the time to finish, but the difference, so tangent of 15 degrees, right? We need to think about two angles that subtract to give you 15. So maybe these are 45 and 30, right? Those are two unit circle angles that would subtract to give you 45. So we're going to employ the formula for tan of 45 minus 30. Okay, so it looks like we've run out of time in class today. The bell's about to ring, but give this one a try. Let's see if we can get the answer to you here in a second. Bam. Quick and clean way to do it. So the answer to this one is 2 minus root 3. Okay, so you can pause the video, try to do it yourself, go back and look at it, think about the math, multiply by the conjugate. This one has a plus in its denominator, so our conjugate has a minus when you multiply by it, right? And then do all the simplifying. It just takes practice. Please put in the time to practice. These are not natural problems for anybody to think about. Okay, super duper. Have a great day.